motor design. By the way, I'm only going to cover solid rocket motor design, so I didn't put it in the title, but I'm only discussing solid rocket motor design. I'm pretty sure you're already familiar with the types of rocket motors, hybrids, liquids. I'm not gonna look into any of that. And inside solids, there are other distinctions, but we'll take a look into that later. So in this section, I'm gonna cover a lot of things. So it's gonna be long. But the good thing is that there's, in my opinion, the available references are much better to study. More than better, I think the most important thing is that they are more comprehensive and more easier to follow for someone that's just starting. So it's definitely much better organized in my opinion. So the good thing is that I think there's just better references. Oops. Let me get rid of this in time. Better references. Let me get the pen. Okay. Available. I mentioned a guy named Richard Nacker before. He's an amateur rocketer that's he's been manufacturing his own like amateur solid rocket motors and flying them for like 30 years, and he has a very popular website in which he documents everything he does. It's just everyone that's into sounding rockets in an amateur level knows who Richard Nacker is. His website is Nacker Rocketry.net, I believe, and it's just great. It's he cross-links a lot of articles inside his website. He has a page dedicated for the theory behind solid rocket motors. It's just a great way to start with. You should definitely combine these videos with what you can find in Rocketry.net if you're starting out, and then there are other references. Many references for solid rocket motor design. The infamous book of Sutton. So this book is Rocket Propulsion Elements. So this book is I think it's interesting for its chapter in nozzle performance. I think the chapter is chapter 2 or 3. So it's nice because it goes very in depth in the nozzle performance, and it's the nozzle performance is the same for solid rocket motors, kind of the same for solid rocket motors, hybrids, and liquids. So it's general, and then it has chapter 13, 14, and something like that. It has a few chapters on solid rocket motors, which are nice, but sometimes it's not going to be so useful in a amateur level. But still, it's a nice read and it's a classic. Then there are other yeah, there's a lot of references, but just to note a few. Davines, book from Davines. Can't recall the title. I think it's Solid Rocket Motor Design. I can't remember. Sorry. And then there's a lot of NASA, like NASA documents. So, which you can just Google them. There's a lot of them, which are a lot of them are nice, because they kind of divide the structure in state of the art, which is like the theory of that is relevant to the design of one part. So maybe, I don't know, state of the art of nozzle materials. So, then there's a section on that, and then there's design criteria. So you have the theory, and then the basic design criteria. So I find it interesting this way to present in the document. So there's a lot of NASA documents out there available for downloading. So maybe one on solid rocket motor. Let's put solid rocket motor cases, propellant, blah blah blah. So yeah, I definitely start maybe with these videos. I think or Richard Naka. I mean, it's a really nice way to start. It isn't too long, very easy to follow, even at entry level, having no idea what solid rocket motors are in general. So what I'll do, I'm gonna extend what Richard Naka puts and Sutton. Obviously, I'm gonna leave out a lot of things that Sutton talks about in the dedicated chapters on solid rocket motors. But again, there's a lot of things that are really relevant to what you would probably do here at an amateur level. Same with Davines. Davines is like, a reference, but a lot of the stuff aren't really going to be that relevant for us. So what I'm going to do in this section is, get all this information I've been reading in the last years and present it to you in everything, in the same, in the same playlist, so you can have it everything in the same place. And if you want to read more, I'm gonna try to cite everything I can. And then again, there's a lot of stuff that you're not gonna find anywhere else, which are gonna be in these playlists, which is interesting. So because there are stuff that we've used in Cosmic, and are very practical, so I think it's going to be relevant for you as well. So in this section, in section 3, I'm going to cover a lot of things. I don't know how long it's going to be, but it's probably going to be even longer than the stability playlist, which at the moment I'm recording, I've done about 20 videos over 7 hours. So I guess it's going to be maybe as long as stability, because there's a lot of topics to cover in solid rocket motor design. So first I'm gonna cover the theory, basic theory behind a solid rocket motor. So as you know, a solid rocket motor, the overall goal of a rocket motor is to give a thrust, a really high thrust, during a few seconds. So I'm gonna cover the basic combustion theory, of solid rocket motors. Then I'm gonna cover also the nozzle theory. Nozzle theory is well, the one you can find in Saturn and NACA is always it's quite simplified, but it's the one that's always used normally, which is the isentropic model. But I'm gonna extend this model to a more general gas dynamic model, which isn't in Saturn or Richard NACA. So the nice thing about the gas dynamic model is that we're gonna be able to model much better the phenomenon of the combustion. Well, the nozzle, it kind of performs quite as an isentropic. Yeah, it's not so bad, but maybe for the combustion, it's gonna be better. It's gonna model a phenomenon that we can't describe with the basic models that Richard NACA and Saturn gives us. Like, you may have heard of erosive burning. Oops. So I'm gonna try to model this in this section. Yeah, maybe also the transients aren't really well modeled in the typical models. So we're gonna get more in-depth view of all the theory. So I'm gonna extend the typical one you find in in the typical references. So theory, then design principles. Of, well, the grain of a solid rocket motor, or the grain geometry. So yeah, not only the typical grain geometry, so you may be familiar with Bates, monolithic. These are typical ones, but I'm also gonna cover in depth star grains, and I'm gonna show you some nice equations to model star grains and to optimize them. So depending on what kind of thrust time curve we want. So yeah, that's interesting as well, and yeah, this isn't from the typical. You won't find this in the typical references. What else am I gonna cover? Well, nozzle geometry. Whoops. Yeah, nozzle geometry is another topic. So trade-offs. The effects of the geometry, the angles, the everything. What else? Design principles. Well, the hardware of a solid rocket motor. So yeah, how maybe in a more practical, fashion. I'm gonna try to talk about the hardware. So, which parts are we gonna need? Which manufacturing methods we can use, etc. Yeah, and more stuff. And theory, design, propellants. Just gonna cover the basic propellants that are in the reach of amateur rocketers. Yeah. So the ones we're going to be able to manufacture in a safe way. What else? Simulation. Yeah, that's another big topic. So so simulation, we're gonna see that simulation of a solid rocket motor. It's not as easy. It's not as easy as to predict. Maybe to model, it's the programs we're gonna need are not that well. They're kind of complicated if you're not that familiar with programming gas dynamic, fluid dynamics. But the thing is, what I mean is simulation of a solid rocket motor is going to be not as precise. It's much more experimental. That's what I mean. So maybe we set up a super nice gas dynamic model and we predict that the thrust time curve is like this, and then we test it and it's more like this. I don't know. It's harder to predict, so it's much more experimental. But still, I'm gonna cover basic simulation. We gotta guess at least what a solid rocket is gonna do before we put it in a test bench. So simulation of the typical models. So the isentropic model is very straightforward. It's very, very simple. But if we want to simulate a more complex CFD model, so yeah, it's gonna be I'm gonna cover that a bit. It's gonna be a bit more complicated, but we're gonna get more information out of it, like erosive burning, etc. So yeah, maybe I'm gonna talk about a bit of simulation, and testing. So testing is gonna be a really big part of designing a solid rocket motor, because the airframe is kind of more difficult to test. So we usually have, at least we're not gonna be able to test it as much as a solid rocket motor, the airframe. Sometimes, but it's easier to predict its behavior, luckily. But the solid rocket motor is very experimental, as I told you. So testing is gonna be a must here. So because it's very hard to predict the thrust time function of the solid rocket motor. It's going to be really hard to predict the if we have any hot spots that just cause our rocket to blow up. So heating is going to be hard to test. Sorry, not to test, to simulate. The performance is going to be hard to simulate. So that's why testing of a solid rocket motor is going to be a must. So yeah, at least all this I'm going to cover in this section. So yeah, it's going to be pretty long, I think. So let's go.